Good morning everyone, and welcome to this session. We have now a 1 hour block with 2 presentations on the multi-station. The multi-station now has been in the market for several years, and it's always amazing to see the applications that it's applied to. This first presentation is especially different and unique, I would say, and I have the pleasure of welcoming Toby Lane, the Technical Director of SMS Worldwide, and Peyton Hatch, our distributor from Kuker-Ranken from Utah. And thank you guys. I'll pass it over to you for a informative 30 minutes.
Good morning. My name is Toby Lane. As was mentioned, I am the Technical Director for SMS Worldwide. We are an amusement ride manufacturing company located in northern Utah. Actually the largest amusement ride manufacturer in the United States. Been in business more than 70 years now. Have ride installations all around the world. Global company. And kind of what brought us to this, as amusement rides get faster and taller and more dynamic forces introduced, we needed a way to make sure that our designs were our XYZ coordinates, all the controls that we manufacture were taken completely through the ride installations on site. So we don't necessarily do all the ride installations, but we have site supervisors that monitor all that. And what we were looking for was a way that we could take our XYZ coordinates, everything that we design and build to, and be able to control those on site. So instead of just standing structural steel, having it be wherever it may fall, and then sending vehicles, sending riders around at 70, 80 miles an hour and having forces, we wanted to make sure that that steel was being placed exactly where our designs intended it to be. So as we started looking into that, exploring different things a little over a year ago, one thing led to another. We were introduced to Peyton Hatch here at Kuker-Ranken. He came in, kind of listened to our needs, what we were after, became a little bit passionate about what we were trying to do, very interested in that. And actually he's been extremely instrumental in everything that we're doing. So our intent was originally by the MS60 to do some control on site, stake out the job sites, some control points, make sure we have it. As we've become familiar with the equipment over the past year, we're exploring different options and different things with it. Again, that Peyton has helped us with. So I'll turn the time over to him, and I think he has a great presentation for this.
Thanks, Zoe. So once again, my name is Peyton Hatch. I'm with Kuker-Ranken. I've been doing this for 5 years now. Kuker-Ranken, we are the nation's largest Leica supplier. So we've got a whole team behind us. We've been doing this for 90 years. So because of the team, I'd say that I got a ton of support, so it allows me to go out there and just focus on my clients. So when they did come to me saying, hey, we have this concept that I've never dealt with before, I was able to pretty much divulge all of my attention to it. And I think we came up with some pretty cool workflows. I'm going to pass those on to you right now. So in the past, they have these really good designers, these really good installers. They can walk out on the site and they can literally look at the site and be like, that's where that pillar is going to go, this is where the loop's going to go. But what happens if they lose that installer and they get a new guy? And they get somebody like me who's never done installations before, but they still have to be able to go out and put these roller coasters up. So they came to me saying, hey, we have a need, we need to be able to incorporate some control and be able to put these roller coasters up, or towers, or anything. So they need to be able to set control all the way around the amusement park, so that way they can set up anywhere and still be able to locate every piece. They need to be able to verify foundation position, so as they go and they put the pillars up, they can make sure that pillar goes in the exact location and that it is rotated correctly. And they also need to be able to verify the saddle points. So this is a good snapshot. I'll step out here so I can use my laser pointer. Everything that they do is designed inside of SolidWorks. SolidWorks, of course, is unitless. They don't care about XYZ positions. So being able to take that SolidWorks design, sending out an IFC file, we bring it into Infinity, rotate the design onto Control, and from there we can go and we can extract positions, XYZ coordinates, of every critical piece that we need to go lay out. So these saddle positions, this is where track meets structure. So we can get good positions, we can make sure it's rotated. Another snapshot of one of the foundation pieces. You know, before they'd be able to locate this position really well, but if it was rotated more than 1/4 of an inch, well, you get that thing 30 feet up in the air, it's just not going to hold together. So by us being able to position all the corners, we can make sure it is rotated. And with the 1/2 accuracy of the MS60, you know, we can guarantee that this thing is placed exactly. So I think we have full IFC capabilities inside of Infinity. It's something the Infinity team's done a great job with. So just a few snapshots. These bolt holes are very small, and it's only our 1/4 inch tolerances because this steel is this big around. We're not going to bend that thing. It's just not going to happen. The other thing that can happen is, let's say we do misalign something down at the bottom, and we get these pieces all installed. Well, then we go to lay the track over, and well, our saddles, we're just not lining up. In the past, we would go put that piece up, and it wouldn't match. And so that was time and money that we're out, because now we either have to remanufacture that piece, that could take a week, ship it across the country, because our manufacturing facilities, they are not on site with the roller coaster. So that was thousands and thousands of dollars. So if we can scan the structure once it goes up, verify, hey, this position isn't where it's supposed to be. Well, we can go to the manufacturer, we can have that part remade or made right before we send it out, and it just saves us time. So we're just snap a few dimensions, we're 6 inches off. That's pretty significant there. So, or we get the part there, we don't have to lift it up to figure out it's not going to match. We can make the adjustments there on the ground before we hook it up to a crane and lift it up in the sky. That's actually what happened with this, and we'll show you that here in just a second. Want to do this one?
Yeah, another thing that we're trying to do, once we have the ride completely installed, ready to go, we would like to have a complete capture of exactly the as-built condition, so that next season or 10 years down the road, whatever it needs, if we need to replace a section of track, or if we need to add brakes in areas or anything like that, we wanted a permanent record of the ride after installation to go along with everything. So we have now taken, in addition to staking out the job site, going out there with the robotic scanner, doing a complete capture of the whole ride. We can take this back. We have very good as-built information of exactly what we have there. We don't have to go out and do additional surveys, additional measurements when we want to add features. So that's what we're trying to do here. The ride wasn't quite all the way installed when this happened, but that is working out very, very good for our people as well.
Some of you guys might be asking, why are we not using just a dedicated scanner? Yes, that would be significantly faster to do that. However, we don't have the layout capabilities, And they wanted to be able to have one tool to do everything. This allows us to do the scanning, to do the layouts, everything's tied to control. It made the learning curve much smaller because, you know, the guys were doing it, they've never ran anything like this, and so bringing out the MS60, I mean, they picked it up really quickly. So, a little for. I'm going to show you some data sets now. So I'm sure you guys have seen enough PowerPoints throughout this week to see something a little more fun and interesting. All right. So this project is called 347. It is in China. I was taking calls at 2 a.m. in the morning. It was great, but that's what we do. We support folks. So, see here, here's the track. This is what we call a launch coaster. People will load right here, go around and shoots them up in a loop. So let's turn off this. Now, if the ride jars you, if the ride is jarring or the G-forces change too quickly, it's a violation. And up until now, we've only been able to guess why are we getting this violation. So one of the violations that was happening was right here on this loop. So we scanned this piece really high resolution. But by looking at it from here, it's kind of hard to say, okay, what is going on? Why do I have a violation? Well, if we go and we overlay the design via the IFC file, it makes it pretty easy to go in here and just quickly visually inspect this and be like, hey, I am 6 inches off. And we can follow this design all the way up until we see where we started to deviate. So these are tools that they didn't exist up until now, or at least in our processes. So yeah, the IFC file is just incredible for us. The other one we had, it's zoomed out here, is right here on the initial launch. Oh, that's right. Sorry, I did zoom too. So you can see we're actually launching too steeply. So that was another violation that now we're able to pick up quite easily. Bring up another.
So this was one of our processes that we're kind of backing into. This ride was actually installed before we had this MS60, before we staked out the job site. We went in here, scanned it kind of after the fact, trying to learn and develop this entire process. And we're able to see this now, which again drives our need that we want to make sure real time as we're going that we are placing those columns in the exact location so that we don't have to try and manipulate this or deal with this after the fact, like what this is showing.
This is another one that's a very similar situation to what you just explained, where it was designed, it was put up before they had the MS60. Now we're coming in and trying to correct a few issues. So this was a project that I actually got to go out on site with. SNS flew me out to New Jersey. This is in Ocean City. And we were trying to figure out the placement of the saddle structures. You can see the track isn't quite done. Now we have this track piece right here. They were installing this as we were going. And then this next piece was supposed to connect to 49 and 50. So I'll zoom in here on 49. And you can see, well, we're 3-4 inches off. And then down here, this is one that I have a screenshot of. This is 6 inches off. So thankfully we knew that this piece literally arrived while I was there and we were scanning it. And we were able to go up there like, hey guys, this isn't going to go together. So we were able to correct it on the ground, put it up, and we didn't have any surprises, which was really beneficial. And if any of you guys were paying attention yesterday during the keynote speaker, we had a picture of a guy up there straddling a pole. I don't know if you guys saw those pictures. Well, that was this project right here. He was actually on this pole right here. And we had our little mini 360 prism. We were taking those shots, so we had some fun while we were working too.
So what this ends up allowing, the benefit for us with this now is when we run into a situation like that on site, instead of just forcing the bolted connection together and then dealing with a violation later, trying to adjust that out, we can now actually make an informed decision. We know where that should be against our theoretical designs. We can make an informed decision at that point of exactly what we need to do with that, instead of have to wait until the ride is installed, vehicles are operational, and we're collecting accelerometer data. So this gives us a tool during the installation process that we've never had before.
All right, so it's great. We're out in the field. We can now put these things up really accurately. What happens if that part's built wrong? That doesn't do us any good. We have to be able to have quality control on the manufacturer side of things. So we go into manufacturer, we can scan a piece, we can then compare it to the design. For this, where you're not going to use Infinity, we are using 3D Reshaper, for the simple fact that Infinity is surface-based. What that means is that Z is up. And if we design these pieces in SolidWorks and we go set them down anywhere, well, we don't know what the orientation is. 3D Reshaper doesn't care about that. It's object-based. So we take a step file out of SolidWorks, put it into 3D Reshaper. Now I'm going to play a little video here, and it's about 8 minutes long, so I'm going to jump to the key parts here. So out of Infinity, we do take a straight PTS file. We'll do a little bit of cleaning, but in all honesty, you don't have to do much cleaning at all, because 3D Reshaper has the ability to take the point cloud and eliminate anything that's not associated to the design. So this particular data set we're bringing in here is slightly clean. Just know that you don't need to take the time to do that. So we bring in the point cloud. From there, we're going to bring in the step file. So this is the actual design from SolidWorks. Those of you who haven't used 3D Reshaper, it's a fantastic tool for this. You can get multiple views. You can do your split view, and it doesn't affect the other view, so it makes it really easy to do visual inspections. Just right now, we're going to do the theoretical on the right. We have the actual point cloud on the left. You spin it around, do a real quick visual inspection. All right, so now we want to put the two together. There's multiple ways that you can put the pieces together. You can do a best fit alignment where 3D Reshaper runs its algorithms and it goes and places the point cloud directly on top of the design. Or you can go pick like points on the cloud, just like doing a resection, essentially saying this point is this point here and putting everything together. But then you're more dependent on your pick points, making sure you're very accurate. Thankfully, with this roller coaster, there are circles, and we can model the circles, the cylinders, then we can pick the exact center. So it takes out our guessing of where we're picking on the structure. So that's what we're doing right now. We're modeling the circles, we're going to draw a circle around it, and then when we go do the alignment, we can snap right to the dead center and snap to it on the design as well, and put these together really easily, very accurately. And so you can see here now the two pieces have been put together. We will accept the overlay. You can see the deviation, it's hardly anything, a couple thousands. Here's the design all put together. From there, we can now run our reports to see where we are deviating. We don't care where the pillars themselves are deviating. We really only care about the saddle points. So you can see this saddle point, there's definitely some deviation there. The heat map, the color map represents just where it's buried, where it's deviating, and you can set the tolerances of those. So you can change your color map however you want. And it does a very good job of putting these reports together as a nice PDF printout. So you can hand this to now the manufacturer and say, hey guys, you built this wrong. This takes the stress off of them, because now if they can prove that it was the manufacturer's fault that built this wrong, well, they're not responsible for rebuilding that roller coaster. They go back to the manufacturer and say, hey, you owe us money, you need to make this for free. This wasn't a design issue on our part, this is you. So huge money saver here to be able to get these reports. And so I'm just going to real quickly show you what the report's like. You can make your edits, add in your own logos, basically customize this to however you want it to be. Last thing that we can do with 3D Reshaper is we can extract a point cloud from the design. So you can take that thing, you can take the SolidWorks file, say extract point cloud, set your spacing, and across every face of that SolidWorks design, you can get a point, an actual PTS file, E57 file, whatever. That can also go into Infinity. And see right here, this is the design point cloud. It's just another way for us to go in here and snap measurements and see where we are deviating. And we can overlay the actual with it. Snap it back on. All right, so I get pretty excited about this though. How many of you here have used the Inspect Surface app? Tony, a couple guys. I should hope all like you guys have. Kevin Hansen. All right, so the Inspect Surface app. This is a fantastic tool for verifying design in the field. So you have the ability to model vertical surfaces. So you can pick 2 points on a wall, essentially create a plane straight up, and allows you to verify plumbness. Or horizontally, you can shoot 1 point on the ground, you create a nice flat plane, and see where things are varying on the flat plane. You can import a surface model. You can do cloud to cloud, so you're scanning a tank. You get a point cloud of that, we'll fill it with water, come back tomorrow, we scan it, you can see how much that tank has expanded. But to get a design of a roller coaster, or say an entire building, a skyscraper that's got a wall here, then it's got another wall right here, you got some pretty cool geometry or architecture with a roof going up in a different plane. Well, you would have to run multiple reports. You'd have to run a deviation report on this plane, and then a deviation report on this plane, same with the roof. And so that is time, that is money. Well, we saw the potential of incorporating the design point cloud into the Inspect Surface app. This way we can quantify the design in the field. I'm going to show you that right now. So this is our CS35 tablet. This can run our robots, run our GPS, and I do have the app in here. All right, so what we got? We got an entire roller coaster here. And I have imported that entire point cloud. There was 36,200 something points. And it runs it like a champ. And as you can see, we have essentially a deviation map. Let's bring it over here. So here's our scale. So anything in green and yellow, that means it's pretty darn tight to what the design is. You can pick anywhere on this design, and it'll tell you the distance to the surface. You can see where you picked. Anywhere, -0.022. If you hold your finger down, if you're hooked up to the instrument, you can tell the instrument to turn and point directly at that spot. You can go fix it before it becomes an issue. So concrete pours, or you're putting concrete on the walls, I can't remember the exact term of it, where you're building out the wall. You can set that vertical plane, and you can now figure out, hey, that spot right there is not thick enough. You need to go fix it right now before it becomes a problem. You can store the point for a report later. You can go hand that out, hand that into your boss, say, hey, this is where we're off, we need to go fix it. So I think this is an extremely powerful tool, just because now we can literally inspect anything. It doesn't care what the geometry is. This roller coaster's got some crazy geometry, and it surfaced at no issue. So that's about my presentation, guys. Does anyone have any questions? Crickets? Think that matter?
Well done. Yeah, awesome.
Thanks, guys. I want to thank Toby and his team for trusting us to come in and show them what we're capable of. I do hope it's been worth it, and thanks for coming down and doing this with us. And
Thank you. Yeah, as Peyton said, of course, we're not surveyors. We're amusement ride manufacturers. So he's had to go way back to ground zero with us and start from really well lower than what he should have. But again, we're fairly new with this. We've only been experimenting this since August of last year, maybe even later. So we're still developing this, trying to perfect this, trying to do it. But what we've been able to do with this workflow in just the last few months is incredible.